Hey all, this is gonna be a video describing when you have 4 corners not in Htr, how you would be able to determine how many quarter turns it has. And essentially this is an example of how Jade McNeil teaches it in his tutorial, and I've just made it in a slightly more condensed table than his video. And yeah, I said this only describes the cases where you have 4 corners that are not in Htr. So in this cube here, when we have the DRs on this axis, you can see this corner is in Htr because it only like has checkerboard colors on the side, so like green matches the blue here. Yeah, so we have 4 misaligned corners here, so this one, this one, this one, and this one. So this is a case where you can use this table because, as I said, there are 4 misoriented corners. So what you want to do is first see the position where they are on the normal, and then you want to see the position where they are on the inverse. And in theory, you could just scramble the cube on the inverse and then see how it looks, but that's slow. So I'll also show you how you can see this on the normal side of the scramble. So yeah, and then we also have to check the parity before we can determine the amount of quarter turns. And essentially you can swap these columns around, so you can have the cases where there are 2 on normal and 1 on inverse, but these are essentially the same case. So what the numbers here mean is the kind of quarter turn lookalike, as Jay calls it. So essentially it means if you are able to have if you're able to set up all the corners on the same side as your DR axis or not, without doing any quarter turns. So essentially, if you have this, I'm pretty sure all of us can agree this is 1 quarter turn. And let's just, for the sake of example, say that our DR is on these 2 axes, which in this case means our DR is solved. You can see all the 4 corners are on this one side. Let me do it on this side. And this case is a 2 quarter turn one, but let's just look at the way that it's the 2 quarter turn lookalike. So as before, we have the DR on U and D, and we have 4 and also as before we have 4 corners which are unoriented for HTR. But let's look at how you can set these up on one side. And essentially you can set you can set them up on one side, which is like how it would be solved, but you cannot set them up in 1 quarter turn where they are on the same side, and then also, or like you cannot set them up with 0 quarter turns on the same side. So here we have this bar here, and it's impossible to like get this bar over here because now they're not all on the same side. So what you would have to do is kind of like this, which is like 1 quarter turn to like be able to have them on the same side. And now we can do the quarter turn, except I did it wrong here. Yeah, so now, So now we move the unoriented bar here, and now we have all the unoriented corners on this side, and now we have HDR corners. Of course, the much more obvious way is doing it like this. So yeah. But yeah, it's essentially the same way. If we had a 1 quarter turn lookalike case, we'd have like the first move I did just before. So we have the 4 unoriented here and 4 unoriented here, and we can move these on the same side like this. So now all 4 are on one side with 0 quarter turns, and we're able to make 1 move, and then we have HDR. So I hope that explains how you can distinguish between 1 and 2. So essentially it is just if you are able to get all corners on the same side which are unoriented, on the same side with what is your DR axis. So now onto an example. Here the DR is made on red and orange. And yeah, so now we want to first look at the normal one, and we want to see if it's 1 or 2 look alike. And we have the 4 corners. It's the same example as before. We have 4 corners here, here, here. So let me just put my fingers on it, and we can see here, there's no way that you can have all of these on the same side in 0 quarter turns, or on these sides in 0 quarter turns. Yeah, it's simply not possible, because yeah, so that means it's a 2 quarter turn one. And then we just want to set it up to this case essentially. Or then we have this case, and we can confirm that because we have 1 bar here and we have 2 headlights here. So that's the same as this. After doing a U2, we have 2 unoriented and 2 unoriented here. And then you have Htr solved, except that in this case you have parity. So yeah, that shows that we have 1 on, or 2 on normal. So it's gonna be either of these 2 cases, or these 2 or these 2. And now we have to trace the RNS, which is, I guess, the hard part for some people. So what you want to do is place, or start placing fingers, but we also want to identify where our solved corners are. So we have there, 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 and there. We want to see where it goes. So this one, it goes here. So let me place my finger here. And it's kind of hard to do this. So let me just grab it awkwardly like this. And this corner, which is also solved, goes here. So now we have 2 fingers here. And this corner would go here. So let me place another finger. So now I have 3 fingers. And this one is still yet to be placed, which goes here. So we have 2 columns again. So again, we have 2 quarter turns. Because just imagine that these bars were unsolved, you would be able to solve them like this on the other side. So yeah, because the corners are like this, we again have 2. So we have 2, 2, and now we have to trace the parity. Tracing the parity is essentially doing a blind solve of the corners only. So I would just take my normal buffer, which is here, and then start tracing. So in my scheme, UA, VB, TD, and CB. And since my blind tracing is now done, and I got an even amount of cases, it means I have even. So we have 2, 2, even, which means it's a 2 quarter turn one. And essentially that means I should be able to solve this and then get Htr, but here we do not, because you can kind of see it's fake Htr. But this video is not really for explaining how to solve this, but if I just were to give it a shot, which I hope doesn't go wrong. So now I already did the first move. Yeah, and this solves Htr corners, except for the edges, but that's another thing that you have to deal with. So yeah, I hope this explains it.